Hello and welcome to another tutorial. This is the fourth part of the series building the hybrid GOAP system. So the last time we had looked at setting up the sort of foundations for the goals and actions. We did very minimal amount of stuff for the actual brain itself. So in this tutorial, we're going to be focusing primarily on setting up the brain, the one that does all of the core sort of planning logic for the AI. So that's going to be the main focus, and there's a lot that we need to build for that, and we won't really see too much happening as a result of it because we're largely just getting the core sort of fundamentals going. So as with all of the other parts for this, in the description below you will find three links. The first is to the code as it currently is at the start of this tutorial video. The second link will be the code as it is at the end of this tutorial video, and the final link will be to the completed package if you're just wanting to jump to that. So let's dive on in. So the focus, as I said, is going to be on setting up our actual brain base here. So the job of the base brain is to handle doing all of the planning. That's its core focus, is figuring out doing the actual planning for the AI, figuring out what the set of actions are, things like that can actually run. So the brain is going to also hold stuff like a list of our available actions. So available actions. It's also going to hold a list of our available goals. So that's an important thing. It needs to have both of those. So that's stuff we're going to want to populate early on. So what I would do is here in our start function, we're going to populate all of those actions. So populate all of the actions. So we're going to say, okay, well, available actions, add range, and we will do a get components, and we'll do a get components of iGOAP action. Then we're actually going to loop through those. And the reason we're going to do that is because what we want to do is say action bind to brain, and we bind it to this particular brain. We want to do the exact same thing for all of the goals. So we populate all of the goals. So exact same sort of logic there, available goals. We add the range, get components like that. We will also, again, loop through these, and we'll do the exact same thing we did with the actions. We bind it to the brain. So that's some essential stuff we wanted it to be doing. Now, there's a couple of other little sort of helper things that I want to connect up at this point as well. So what I'm going to say is that we'll have some support for children of this configuring the Blackboard, and there might be some final configuration of the brain that the particular child ones of this might want to do, but we'll allow them to do that after all of the actions have been added. So that looks good. Now, in terms of with those sort of particular functions, what those will actually be is those will actually just be a public, actually that will be a protected abstract void for configure Blackboard, so we force any child ones to have to implement that. And the same thing for the configure brain. There's something where if child ones are going to be based off of this, I want to enforce that they actually consider, yep, is there initialization stuff that we should actually be doing at this point? So I think that's an important thing. So, okay, that's pretty good for our logic in start. We've already got on destroy set up. We'll set up our update. So our update function, well, one of the things we will do is our current location. We're going to update that so that we can rely on as always being up to date. And I'll also set up a tick brain function. That's going to handle, and I'll provide a time.delta time to that, again, in case things might want to mess with that. So the idea is that tick brain is going to handle sort of the core logic for the updating. So we'll have a tick brain float in delta time. Now this is one that it's less common that a child class might want to override it. So this is one that I will make a protected virtual void. And I'm actually going to set up two things here on prepare to tick brain and one that will run at the end. So I might call it pre-tick brain and then a on post-tick brain. Just in case there is any specific stuff that a child one might want to do, I just want to have those bracketing sort of hooks either side. The actual core tick logic, I don't really want to support child ones being able to override it at this stage. So that gives me the starting point for this. First thing I want to then do is let all of our goals update their priorities. So we prepare for planning. So for each goal in our available goals, we will tell it prepare for planning. So now all of the goals will have calculated their priority, which will also determine if they're going to be able to run. So what I would do is sort the goals in priority, and I'm going to just do that by saying available goals sort, and this is where I can give it a simple little sort of predicate. I GOAP goal in RHS, and all this will do is we return RHS in RHS priority, and we compare that to the LHS one. So this will sort them so that the highest priority goal will be at the lowest index. So then, if we've got no goals that can run, then that's one scenario that we could have. No goals or none that can run. And I might actually flip this to, do we have at least one goal that can run? Just makes it cleaner with the post-tick logic. So if we do have that, so if available goals count is greater than 0 and available goal 0 is valid, then we can actually run. Otherwise, there will be logic that we need to do here. So if we already had a current plan, we would need to stop it. Otherwise, what we'll be doing is we will build a current plan. And so this is actually building a candidate plan. Then we would evaluate that plan. So we figure out a candidate plan, then we decide, okay, is that plan going to be a viable one that we want to actually switch to? And then what we would have here is tick the plan if valid. So I've got a few things that we'll need to set up that we don't currently have implemented, but that's okay. So we've got that. We'll have the same thing with our evaluate. So, okay, that's going to be the bulk of sort of the logic in terms of that initial structure. There's going to be a lot of other things we need to actually set up. And we need to have this concept of a plan. And that's actually going to be quite a large chunk of the logic. So with the setup that we're going for here, a plan is comprised of one or more pairs of a goal with an action. So those elements will be what we define as that pairing of a goal and an action. So what I'm going to do is I'm going to create a class here that I'll call GOAP Plan Element. And what this is going to have is a public iGoap goal. We will make this publicly gettable, but a private set and default it to null. We'll do the exact same thing for the action. I'm going to create a couple of easy helpers for accessing things like the priority. So we'll have a public int priority. So if goal is not equal to null, then we use the goal priority. Otherwise, we set it to goal priority do not run. So that's good. For the cost, we have a similar process where if we have an action that is valid, then we use our action and we use the calculated cost. Otherwise, we set the cost to 0. We could go instead for float.maxValue. So it's essentially a highly costly action that probably makes more sense than a do not run. We want to be able to know what resources something uses. So the resources used, well, if we, again, this is a similar thing, if the action is, do like that, oops. So if action is not equal to null, then we use action resources required. Otherwise, we say none. So a couple of little helpers that'll make it easier for us working with this. So that's good so far. What would also then be handy is we're going to have a lot of interfaces in this for actually, executing stuff, things like of that. But I also want this to support being able to be tested if it's equal, things like of that. So I'm going to bring up our little sort of helper stuff. And we want to generate our equals stuff. So we only need to check the goal and the action, like that. So that's good. We've implemented the equatable. The default setups for those are all good. So, okay, now we can focus on kind of sort of the key bits we need to actually add in addition to this, which is we want to have an interface for saying, okay, well, I want you to start this plan element. So start element, all that's going to do is say goal.startGoal and our action.startAction. Unsurprisingly, we're also going to have implementations for continue and for stop and for tick. So we'll have tick element, we'll have stop element, and we will have continue element. And we just map these to the particular functions because we're always starting ones as a pair or continuing them as a pair, and we want to make sure we always do the stuff for the goal before the action. Now, the goal is generally not going to be doing anything with those, but that's okay. It's really about making sure we've got those interfaces there for it if we need it. So in delta time, so we have our tick goal and our tick action. Cool. So that's it for our plan elements. I could make it a little bit cleaner constructor-wise and allow us to have just a constructor that looks like that. But I'll just rename these to in goal and in action. So that's good. That's an individual element of our plan that defines that pairing of a goal with an action. Now, the actual plan itself, I'm going to wrap that in its own class also, because I think that's going to make things a lot easier also. So we'll have a GOAP plan. Now this is going to have a public list of GOAP plan elements, and this will be our elements, and that is publicly gettable, privately settable, but we will new that to an empty set of things like that. Now, this is something where we, again, similar to the other one, we do want to be able to check for equality with this. So I am going to implement the operators for this. It's going to be something that I do modify slightly, but we'll get to that when we hit that particular point. Because there's a couple of other things that I'm going to want to be able to do with this. So what I want to have is, because the plan needs to keep track of those elements, but then there's also a bunch of derived things that's going to be useful for us to keep track of. So our base priority, this is the priority of the first element, which will actually always be the highest element in the plan. So if plan elements, elements dot count is greater than 0, then this is elements 0 priority. Otherwise, this is going to be goal priority, do not run. So that's good. We want to also, to make it easier because we can run multiple goals and actions at the same time, I want to sort of, with this plan, evaluate kind of the overall importance. So I'm going to also have a cumulative priority, and this is going to be a similar sort of setup, but this is actually going to be one that we will calculate. Similarly, I want to have a cumulative cost. And that's going to be our float max value. So these will be useful for when we're evaluating particular plans. I want to also have character resources. So I want to know the resources that are available. So essentially the ones that are left if we're not using this plan. Well, if we're using this plan, what resources are currently left over? So that, again, publicly gettable, privately settable, and that actually should default to none. But I then will also have a resources used. Sorry, that defaults to all. Resources used will default to none. So, okay, a lot of sort of setup bits there that we do need. We do also then need to provide our interfaces for the start, continue, stop, things like that. So we're going to get those set up first. So public void stop or start. That's going to just do a for each. Whoops, not that. For each element in elements. And we will just do element start. We will have quite similar for things like our continue, stop, and we will also have a tick. So continue, well, that just is going to run continue element. Stop is going to do the same. So, okay, starts all good, continues all good. Stop, we actually want to have a bit more flexibility with this because we potentially have two scenarios with this plans where we're doing stop. One is just using it as a cleanup. The other is actually properly stopping a running action. So I'm going to have a bool b send stop notifications. And if that is set, then we actually tell the elements to stop. But outside of that, when we stop, we are going to clear those elements. We're going to set the priority to our goal priority do not run. We're going to set our cost to our max value. Set our resources available and our resources used back. So stop kind of functions as a reset, essentially. We have our tick function, which takes in our delta time. So that will tick element, and we have in delta time. So that's good. We've got those sort of common interfaces there set up. We want to start to set up things for being able to add things to the plan as well, because that's going to be an essential thing that we need to do. So we will have a public void add element, and that takes in a GOAP plan element, like that. Then we'd have plan elements. Oops, sorry, that would be elements.add, like that. Then our cumulative priority, well, if our elements count is 1, then what we actually do there is that's just going to be our in-element priority, because this is the only one we've added. Otherwise, it ends up being cumulative priority plus in-element priority. Now, there's kind of a couple of ways we could clean this up and make it a little bit neater. So what we could do is change this around so that it actually functions more like this, where we say the priority is that. That's going to work a little bit neater. So if the elements, we've only got one, then we're using 0. Otherwise, we're using the current cumulative priority, and we always add in the element one. The current cost, cumulative cost, goes through a similar process. So we have the cost efforts at. So that's good. That allows us just to handle resetting while still having it that the priorities and costs can start at invalid values. Otherwise, we'd need to start these at 0. And I think better to have it started at something that makes it clear that it's invalid. Resources used, we need to keep track of. So the resources used, we do an OR equals with our in element and the resources used. Then resources available, we do an AND equals, and we do the ones complement of in element resources used. So that will just clear out only the resources that were actually used by it. So that's good. That gives us our initialization logic. So, okay, we can add an element in there. Then with the plans, one of the things that we are going to need to be able to do is support doing a deep copy. So I want to have a copy from where it can be given another plan and it creates a full copy of that. So what I would do in that case is firstly stomp our current plan, if there is anything, but not sending notifications, we're just wiping it out. Then for each var element in our inPlan.elements, and then I would say add element, and we specifically do a new GOAP plan element because we're wanting this to be a full deep copy. So we would have element.goal, element.action, like that. So that will give us our deep copy of the other plan. So that's good. Now, a couple of other things that we need to do. I do want to clean up and make some changes to this sort of equals one, because that's some stuff that we will be needing. There's a couple of other helpers that I know we're going to need. So I know we're going to need a way of checking if a plan contains a particular goal. In goal. So what we do with that is by default we'll return false, and we will just loop through every element in the elements, and if element goal matches, then we just return true. That's going to be really handy just to know if a plan has a particular goal in it. That is a thing we are going to want to be checking. Now, in terms of our equality checking here, so because we want two plans to be considered equal if they contain the same combinations of goals and everything. So we don't want it to just be doing a comparison on the list like this. So what I'm actually going to do is F, and I will rename this in other. So F in other is not equal to null. If it was, we would just return false. And I'm going to, by default with this, return true. And then, okay, well, F plan elements dot count is equal to in other plan elements. That, and that actually should be elements. So our return true goes inside that. So then what I want to do is loop through each of the particular ones. So we'll have index is 0, like that. And then I want to check, okay, well, if this plan element, if element index, if that is not equal to the in other element, index, then we return false. So we're just making sure that we're doing a comparison if essentially the elements are the same. And if we take a look at what our actual element comparison is doing, then it's going and checking those particular goals. So that's why we're going for doing it this way. Just ensures we're properly checking if the plans are actually the same. So that's good. We've customized the behavior for the equals setup. The other thing that we should do, just because it would be a handy thing to have, we already have stuff with the cumulative priority and everything. I'm going to just create a public bool, and this will be our is valid. And so this will do a get. So by default, it's going to return if true if elements count is greater than 0. But then what I will do is I want to check every element. And if any element is invalid, then the plan is considered invalid. So if element, and we check if it is valid. So for an element being invalid, we'll add that check in a second. So if element is not valid, then we return false. So the actual element itself, we will set up here, and element will be considered valid if the priority is greater than or equal to goal priority. Actually, I can check the goal itself is valid. So if goal is not equal to null, we use that. Otherwise, it's invalid. So we're just really sort of setting up a bunch of helpers here to make our lives easy for duplicating plans, for checking if they've got particular goals in them, for different sort of aspects like of that. The final thing I need to add to this plan, and there is a lot of setup stuff for this, but the final thing is when we switch from one plan to another. I want to have a bit of a wrapper for that. So this is actually going to be a static function, and this is going to be called migrate. So this is going to migrate from a current plan to a new plan. So a couple of scenarios that we could actually have here. One is we want to look for any sort of elements that are fully stopping. So are there any elements that are fully stopping or continuing? So essentially something that's either there and needs to stop or something that is there and needs to continue. So we loop through element in that current plan like that. And then we check, okay, well, if the new plan, if the element contains that, so if it actually doesn't contain it, then that means that that element is stopping. So element dot stop. Element is not continuing. Otherwise, that element exists in the new plan and it is continuing. So that handles fully stopping or fully continuing. So on a whole element basis, then are there any elements that are starting? So for this, we loop through the elements in the new plan. And then we do a similar check. Element is starting. So if the current plan does not contain that particular element, then we can say that that element we started. So we just handle the migration through this. Just makes it a little bit easier. It's a little bit less we need to be burdening the actual main GOAP brain with. It keeps things a little bit more partitioned, which does make our lives a lot easier. So now that we've got that, there's actually a couple of other things we can populate down here, because we had some areas that we couldn't fully set up in our ticking logic here. So here, where we would go and tick the plan if it was actually valid, well, what I can do is say, okay, well, if our current plan, and this will be, we'll call it active plan, and we haven't actually created the variables for that. So that's the other thing we'll do now that we've got those classes, is we will have a GOAP plan, active plan, and very importantly, we only new each of these once. We don't actually new them multiple times. Wanted to try and minimize, where possible, memory churn. So if our active plan is valid, then we would go active plan, and we will tick it with the delta time. So, okay, that's sort of that part of the logic there. Well, we can also do this handling of stopping the plan if we need to. So what we would do is we would do active plan, and this is a case of if we have an active plan, because we might not. But the active plan is never going to be null, so it's actually always going to be safe for us to say active plan stop. And this is a case where it actually should send those notifications. So that's that part of the tech logic. Now we get to the fun part for building our plan and evaluating it. So there's a little bit involved to this, but it is a really essential part to it. So if we remember with the general aspect of how this was going to work, our goal is we want to support running multiple goals at the same time in parallel, and we essentially run the goals filling in priority order, and providing that action resources are available for them. So there's quite a bit that we need to actually do there for it. So we're going to dive in and get that set up now. Okay, so let's get this set up. So the first thing when we're building a candidate plan is we're going to wipe any existing one we might already have. Wipe the candidate plan. So candidate plan, we're going to do a stop, but this we pass in false. So anytime we're stopping the candidate plan, we don't ever want it to send notifications. We just want to clear out the data so we can actually perform the planning process itself. So now that we've wiped the candidate plan, we can start actually building things in it. So the first thing I want to do is, because we've already gone through and sorted the goals, I can actually just iterate over the goals to be building the plan. And that means I will automatically be building it, populating the highest priority goals first, which is the really sort of important aspect for it. So I loop over, and this will be a candidate goal in available goals. And so now we need to evaluate if this goal is actually viable. So if the goal is not valid, then we just skip. So that's going to be the case. Some goals will not be valid, so we just don't actually even consider them for planning, regardless of their priority. But if a goal is valid, then we need to find the best action to actually support that goal. So to figure out if an action is suitable, well, what I need to do is firstly take a look for appropriate actions. So try to find the best action. So, okay, we want to say that we're going to default it to null. So our best candidate action will be null. We'll also keep track of the cost for it. Cost, and we'll set that to float max value. And I want to loop through all of the action. So for each action, we'll call this candidate action, in our available ones. So for each of those, now, one of the things is an action just might not be able to satisfy the goal. So if candidate action, we'll check, can it satisfy the particular goal? And we want to continue, but specifically invert that. So if it can't satisfy it, then we skip it. There's nothing to do for it. Then we need to check if we have the available resources for it. So do we have the resources, or are the resources not available? And this one is action can't meet goal. So for knowing if the resources are available, we can check, okay, what I'm going to do is actually cache the resources needed. So that's our candidate action, resources required. So we've got a couple of scenarios that could happen with the resources needed. One of the key things is that it could be that they're not available. Now, I want to sort of handle the case of you could have an action that needs no resources at all. It might just be sort of a little bit of a background worker. So I'm going to specifically check if the resources needed is not equal to none. So if we are actually needing ones, and if the resources are not available. So if candidate plan dot resources available, and what we do is we can say has flag resources needed. So this is going to tell us, we actually don't need the extra braces or ones around that. So if the resources are actually needed and they are not available, then we do a continue because we couldn't actually use them. So now it starts to get a little bit more complicated. Now we've got an action that's a candidate one that we know we can satisfy, or it can satisfy the particular goal, and we know we've got the resources available for running it. So now it gets down to, well, there might be one that's a better cost. So we need to look at the cost aspect of it. So for checking with the cost, what I want to do is I want to keep track of what the cost is first, because that cost function does, it does take time. It can be an expensive one, so I want to actually be caching that cost. So we'll have our candidate action calculate cost like that. So, okay, we've got a few scenarios again of what could happen here. So, simplest scenario is going to be, okay, well, we may have no best candidate action at this point. So we still may not have actually selected a optimal one. Or what we could have is that the candidate action cost is less than the best one. Now in that case, quite straightforward. Our best candidate action becomes this, and our best candidate cost becomes that. So that's simple scenario. So in this case, either no current candidate or this is cheaper. The other scenario we could have is we could get an action that has the exact same cost. So we could have, now this would be rare, but it could happen. So if best candidate cost is equal to candidate action cost, so we've got two actions then that both can satisfy the goal, both have the resources that they need available, and both have the exact same cost. So this is a rare case of matching cost. So if that is the scenario, then this is where my resources helper that we set up, we count the bits. So we get the number of resources used by our candidate action. And if that is less than our get number of resources used from our best candidate action, then what we actually do is we use the one that uses the least resources. So we do the exact same logic here. So the idea behind this is use the one with the lower number of resources, because that would allow us to run the most goals. So that's part of what makes this a little bit more complicated from the planner side, and why it is its own separate tutorial, is because it's very, very easy for us to have quite a complex set of use cases for this. So, okay, that looks good. What I would then do is down here, if we didn't find a candidate action, so if best candidate action is null, then we just do continue, because we didn't actually find a valid one. So no valid candidate. If, however, we did find one, then we can add it into the plan. So we can go and say candidate plan, and we add an element, and that ends up being a new GOAP plan element with our candidate goal and our best candidate action. So it's a little bit involved. It's more than a little bit involved, if we're being honest. There's quite a bit to this, actually. But the key things that we're doing is we go through the goals in priority order. That is then, and we've already pre-sorted them, we skip any invalid ones, and then when we're finding an action, we make sure that it can satisfy the particular goal, and that we've got the resources we need, and then we check on cost, and then finally, if the costs happen to match, we check which one is using the fewest resources. We do intentionally support candidates getting added that have no resource cost associated with them. That's an intentional thing that we do want to make sure we support. So now we need to decide what we do when we've got a candidate plan. And there's a few different scenarios that are going to need to be able to be supported here. So we're going to add in them, and that's going to be sort of the core of our logic for this all set up. Okay, so a couple of scenarios that we could have. First scenario is actually the easiest one. So we have no current plan, but a valid candidate. So with that, okay, well, if our active plan is not valid and our candidate plan is valid, then really straightforward. We start the plan. So we would do an active plan copy from the candidate and an active plan start. So that's our easiest use case. That's really only going to be the case at sort of starting point. The more common case that we will have is we will have an active plan that's valid and a candidate plan that is valid. That's actually going to be what the majority of the time the scenario is that we will have. So with that, one of the scenarios is identical plans. So if that's the case, so if active plan is exactly the same as the candidate, then all we do is active plan, continue. So that's actually a really easy one to handle. The other scenario that we could have is they are different, and then we need to figure out which one is better. So scenario 3, different plans determine the best. So what we do in that case, and this is where and why we had sort of the stuff like the priorities and the things like of that we were setting up. So if the candidate plan's base priority is greater than that of the active plan, so the new plan is more important. So new plan is more important, so it has a root goal that is a higher priority. So if it is more important, then what we will do is this is where we use our migrate function because we're kind of interrupting. So we go from our active plan to the candidate plan. And then that only handles the starting and stopping. That's all that is actually doing. Then we tell our active plan we're going to copy it from the candidate plan, like that. So that's good. We do the migration, and then we update the active plan. Otherwise, the other scenario we could have is the goals might be the same priority, but we've got different sort of level of cumulative priority. So same base priority, but higher cumulative priority. So the overall both plans, their top level goal is got the same urgency, but we're looking for if the candidate plan overall with the set of goals that it's running, they have a higher urgency. So essentially if it's doing a more important set of work. So else if candidate plan base priority is equal to the active plan's base priority, and we also, as part of that, check what we're looking for is that the candidate plan's cumulative priority is greater than the active plan's cumulative priority. If that's the case, then we do a similar sort of process of we migrate and we do the copy from logic. So that's good. Then the final scenario that we have is scenario 4, no valid candidate plan. So in this case, we know that if we'd had no active plan but a candidate, then we would have gone into here. If we'd had an active and a candidate, then we would have gone in here. So the only way we can get down here is if we have no valid candidate plan. Now, in this case, if the active plan is valid, we are actually going to stop it. And the reason is that we have evaluated everything that we could do, and we have decided that there is nothing that we should actually still be doing. So candidate plan also indicates if we should actually be doing stuff. And actually that false should be true because we do want to send notifications. And then down here, we do a stop, and we don't send notifications. And that is actually pretty much it. If we only take a look at the final thing that is worth updating, is this get debuggable object content. That's one that we haven't really actually done anything to apart from supporting the debugger. But what we can actually do is for each the element in our active plan elements. So, okay, let's output the data for the goal. So we gather debug data and we give it the debugger and effort selected, which for this, well, we're already opting out here if that's false. So we actually can just always pass true in here. So, okay, we output the goal first, then I would push the indent, and to make sure we don't forget, we pop the indent as well. And in between, we would do element, action, let it gather debug data. So this is for the active plan. Then what I would do is for each var goal in available goals, because we'll have goals that aren't actually running, and it could be useful to know that. So if the active plan contains goal, and this is where we set up that function. So if it contains it, we do nothing. But otherwise, what we do is we would say goal, gather debug data, debugger, but in this case, we would provide false. So we're saying that it's not selected. So this just allows us to, the active plan will always be drawn first. We can see all of the data for it, and then we can see, okay, what are the other goals that allow us to see things like their priorities and everything still while stuff is actually running. So that's good. We've got a lot of those bits that are set up. We do want to check for, there will be absolutely a few errors, which is fine. So configure Blackboard and configure Brain. There's nothing specifically we need those to be doing, so that's okay. We're going to just test that this is still happy with us. Now, we won't see anything different in terms of functionality, but the brain itself would be able to be ticking, so that's good. So, okay, we've got everything set up there for the core part of the brain. We don't have implementations of our actions, things like that yet. That's going to be the focus of the next tutorial. The final little thing that I will get up and running for this, just because it's something that is going to be a common thing we use in a lot of the areas, is I want to set up another interface. And what this is going to be is this is going to be a GOAP navigation interface, because a lot of our actions, things like that, are going to need to be interfacing with the navigation side of stuff. So I want to define an easy interface for it. And this is an approach that I want to later on roll out to things like the awareness systems, stuff like that, as a way of allowing the behavior side of things to be a little bit more distanced from the specifics of how some of the dependent systems work. So there's going to be a couple of things we're going to need. I want to have a function that sets the move location, and that's going to have a owner or a mover. It's going to have a location, so that'll be the destination. And I want to also be able to provide a stopping distance. So that's going to be one function. I want to also know okay, is pathfinding or moving? And again, we have our mover, because that's going to be a useful thing to know. I also want to know, is it at the destination? So again, we provide our mover. I want to be able to stop the movement. So stop moving. Again, has a mover provided to it. And the final thing, because this is also something that is useful to be able to get from a navigation system, is find nearest navigable location. Again, we have the mover. We will also have a location, and we'll have a search range. So I'd actually call that in search point. So I want to have this interface available to all of the actions, because I think this is a really core critical thing. So I will actually, in all of the actions, I'm going to put, and I'll put it pretty right up the top here, have a protected GOAP navigation interface. And this is our nav interface. We could call it navigation. So that's something that is going to be really important to exist. And I will populate that already actually in here. So we're going to do a get component, and I want to find whatever implements that GOAP navigation interface, because that's going to be really critical to make sure that we've got sort of access to that, because that's going to make it easier for us being able to work with them. We don't have a concrete implementation of this yet. That's okay, but we'll do the concrete implementation in the next tutorial. This is just more defining so that we've got that ready to go and ready to be made use of in the future ones. So we've got our brain up and running. Next time we're going to be diving into implementing specific actions and implementing them for the particular scenarios that we're working with. So that's going to be the big focus of the next few videos that will be coming out. Thanks, folks. I hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It does really help out. It's really appreciated. If you are looking for the code for the project, so you will find 3 links in the description below. The first is a link to the code as it was at the start of this project. The second is a link to the code as it was at the end of this project. And the final link is a link to the completed package that you can use via the Unity Package Manager. So all of those will be in the description below. If you have got any questions, chuck those in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description as well. But until next time,